This is the Forensics Timeline 1 picoCTF challenge from the picoCTF 2026 competition. In this challenge, we have a disk image where the attacker performed an anti-forensics strategy to cover up their tracks. And we're going to use the Sleuthkit to rebuild the timeline and try to find out what they did. So let's get straight into it. I already downloaded the file and gunzipped the partition image, so now we can get straight into solving this challenge. First, we need to construct the Mac timeline. To do that, we have to make the body file first, and to do that, we run fls-m. M stands for Mac timeline, and then slash, that's basically starting at the root of the partition image. -r stands for recursion because we want everything, and the partition image. And we can just output it into a text file named whatever we want. I just named it bodyfile.txt. And now we have to generate the timeline, so we can use mactime for that. Mactime and then -b, which stands for body file. So we can just type in the body file name. -d stands for output as a CSV format. This just basically makes it easier for us to analyze the timeline. So let's go open it up with whatever CSV viewer you want. And now we can see that there is a lot of stuff. So Mac timeline stands for modified, accessed, changed, and birth. So modified is when the contents of the file are changed. We can see inside the type field anything with an M, that means the contents of the file were changed. Like if someone was typing into a text field or someone saved a file. Access is when it was read or opened by anything. Changed is if the file was renamed or if permissions were changed on the file. And finally, birth is when it was created. So some key patterns to note is if there is a macb, which is, for example, at the bottom here, we can see a macb. That means a new file was created, and the file was created to, written to, and the permissions were all set at the same exact time. So that just basically means this file was just created. If it was m.c, something like this, that just means like a content update. So the contents of the file would change because it was modified and it was changed. A means someone just opened and read the file but didn't really change anything. And C is a cover-up where someone just renamed the file or changed its permission without touching the contents. Looking at this timeline, there is a lot of stuff. There's 23,000 rows of files and events. Based on the hint, we can see it tells us to look at the recent timeline, pay close attention to the timestamp near the anti-forensics action, and only look at files by grepping for macb. So let's go filter the rows so it only shows macb or when events where files were actually created and only created. So we can do inside of LibreOffice, data, more filters, standard filter, and we can filter for macb. And there we go. So it tells us to look at the most recent events. We scroll down some more. We can take a look at these. And if we look closely enough, one that stands out is this line right here. So this is most likely the anti-forensic action because having the ash history created, which is what macb is, the file is created, is extremely unusual because the ash history, the root/ash history, is normally created when the Linux system is created itself. So this means that the user most likely deleted the old ash history, which is basically a history of all the commands that the user had ran, to remove all the traces of the commands they ran on the system and created a new one which has no history of the commands that they ran. Because of that, let's look at files close to it as the hint says. And we can see this suspicious file right here, /etc/chat. That is not a normal file that should be inside of the etc directory. Because of that, let's go take a look into what is this file exactly. So to view the file, we have to get the inode number, and that is this number right here. So we can go view the contents of the file using icat. We do icat and then the image partition name, and then paste in the inode number. We get a base64 encrypted string. So let's go base64 decrypt that, echo the string, and then base64-d. And we can see that we got the inside contents of the flag. So let's go submit that. And then there we go. If you learned anything new in this video, or this video helped you out in any way, shape, or form, please like and subscribe. And please go check out some more walkthroughs from challenges from the picoCTF 2026 competition. Thank you, and see ya.